Hello. So in the last video, we looked at this thing here, um, and we saw it was a display, and we started to play with the display by messing with this down here, and that's where we're gonna continue here. We're gonna count in binary, and um, I had done this. I had made this video a couple of times. I don't know what the best way to do this is, but I'm gonna. I kind of like myself, and it helps me when one needs to count in binary. There's a pattern you can draw. You bloop. Um, so the pattern starts here. It's a zero, and then we have something, and then a zero, and then a one, then a zero, then a one, then a zero, then a one. The existence of the wire is a one, and the green is a zero in this drawing that I'm showing here. Now let's see, how far should we go? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's as far as we'll go. That's as far as we'll be able to count. And then now we're going to go 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Okay. And now we're going to go, instead of 3, we're going to go 4, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. And now this time we're going to go 8. We're doubling each time. So 0, 0, 0, 0, 0, 0, 0, 0. That's 8. And now 1, 1, 1, 1, 1, 1, 1, 1. Okay. And that is how you count in binary. Let's convince ourselves that that's true. We'll make some button doohickeys here. Maybe I can get away with doing it that way. Okay. We'll also want a button for this. And we'll turn this one on. That's the one that says to care about the other things. So we want it to care. So it should show a 0 right now. Let's see if that's true. It is. It's a 0. Hooray. Okay. And we're going to go through all of these numbers and see them on the display. What's the next number here? So the first number that we showed was this top one here, 0, 0, 0, 0. The next one is 0, 0, 0, 1. So turn this on. These represent the zeros, and this represents the 1. And this is the number 1. Let's verify. Ta-da! Okay. Now, the next number is 1, 0. So we have 0, 0, 1, 0. Okay, so 0, 0, 1, 0. This should be the number 2. Ta-da! It is. Okay. The next one is, let's see here. Maybe we can mark off the ones that we've done. Do it. So we've done 0, we've done 1, we've done 2, and now we want to do 3. So 0, 0, 1, 1. All right. Easily done. 0, 0, 1, 1. Okay. And it is a 3. Huzzah. Okay. The next thing is 0, 1, 0, 0. Mark off that we're there. Okay, so 0, 1, 0, 0, 0, 1, 0, 0. And we get 4. One thing I want to point out is that there's a kind of similarity between going from 99 to 100, or 999 to 1,000, or even from 9 to 10. There's a kind of similarity in that with what's happening here when we went from 3 to 4. 3, this is kind of like 11. I mean, it's written out 11, 1, 1. And binary only goes up to 1, so 1 is kind of like 9 as far as binary is concerned. It's the biggest number you can have, biggest digit you can have. So it's kind of like 99. And you add 1 to it, you go to the next number up, and it's going to be 100 with regular numbers, with decimal numbers, and with binary numbers, it will be 100. It'll be 100. It'll be a number that looks visually like 100 if you didn't know that it was binary. And that's just the next number up from what was 3 and what is now 4. But that's the pattern that we're following, which what we did here with kind of 0, 1, 0, 1, 0, 1, this kind of makes it easier to draw it out because there's a very distinct pattern when you go down it like this. But if you are just going from each digit to the next, then it's less obvious. I mean, it's you can we do it when we count, but there's more than one way to look at this, and I want it to whatever. So that's 4. Let's go to 5. Okay. We could go down here, but I'm gonna just count. I think that you can you can verify, and you'll be able to see what I'm doing here, but just to make it faster. So we're at 5. So let's go to 6. So 6 is going to be this guy, but not this guy. So that's 6, and 7 is just turn that one on. Now we're at 7, and now this is kind of like 999. We'll have to go up to 1,000. So you want to turn this one on and turn all the other ones off to get to 8. Okay, so here we are at 8. And now here's 9. If we just look at the bottom 3 bits, it's kind of like the number 1. And then this bit in itself kind of represents an 8. This is 8 plus 1. In fact, you can keep, this is the eighths column. Kind of like in base 10, you have the tens column and the hundreds column, the thousands column. This is the eighths column. You can either have an 8 or not. This is the fours column. You can either have a 4 or not. We don't right now. The twos column, you can have a 2 or not. We don't. And the ones column, you can have a 1 or not. So we do. We have an 8 and a 1, and that gives us 9. If we want to get 10, then we need to add 8 plus 2. So, and we need to not add this 1. And this gives us 10. Now, this is a way to represent 10. This is the letter A. There is a base 16 system called hexadecimal, and it has digits that go up to 16. There are 16 digits. And it uses the regular digits up to 9, but then it uses A, B, C, D, E, and F for the remaining digits. So here you have the A. I drew it capital case because I couldn't draw it lowercase. Anyway, that's 10. Now we're going to go to 11. And here we are. B, which I drew as lowercase, because if I drew it as uppercase, then it would look like an 8. Okay, so the next number, like we have these two, these are both on, we have to jump to the next digit. This is kind of like going from 99 to 100 again. So it's going to be bloop, and these two got to go off. C. I could have done a capital C, but right. Next should be D. And again, this is a lowercase d, because a capital D would look like a 0. Okay, so what is D? A is 10, B is 11, C is 12, D is 13. So now E is going to be 14. Here we have E, has to be a capital E, because how could you draw a lowercase e? Maybe you could put this here, but then it would look like, well, maybe, I'm not sure it would look like an E. Maybe it would. Anyway, now we're going to go to F. F is 15. Here we go. And F is as big as we can go. All of the things are ones. The next digit would make, this would be like 9,999. The next number would be 10,000. Which is basically a 1 with 4 zeros, so these would all be zeros. But that's already taken up as 0. So this is as high as we can do with this machine. Okay, now there's all of this stuff sitting between the inputs and the outputs. We know how this thing works, and we know like somehow these connections are puppeteering these signals. But what is all of this? There are roughly 3 components here, which we'll go over. There's this thing. This is, roughly speaking, a holding area to store the most recent number, because this thing will turn off. This guy here will turn off, and when it does, it still shows the number, and we can change these things, and they don't change the number anymore because this thing is off. But it still remembers the number, and that remembering is done here. And then there's this part here, and it, roughly speaking, figures out which number it is. And what does it mean it figures out which number it is? Well, it converts, like the number here is represented very compactly as 4 bits. This kind of it expands it into a different representation that is much less compact. You may notice that there are these wires kind of sticking out on regular intervals, sticking out of here. And there are 16 wires sticking out of it, and there's it's no coincidence that there are 16 digits that can be shown. F is 15, so you might think there are 15 digits that can be shown, but no, there are 16 digits that can be shown, because 0 can also be shown. And each of these vertical wires here represents a digit, and you can see one of them is showing up. There will always be only one of them that's showing up. We can even, like, this video is going to end in 20 seconds, and we'll go into it in more detail in the next video, but we'll see one of these wires change here just for fun. We'll have to turn this guy on so we care about the input again. Okay, so you can see it's now this wire that's on. And if we change one of these buttons, it's going to do something, but it's a different single wire. Now, there's something going on over here, but there's always one wire poking out. Do that. Let's see. This again, there's one wire poking out. Okay. Stop video recording.